Okay, so we're on for the last part of the project. Aerial photography is taking photographs from an aircraft or satellite. It makes it possible to measure some distances such as the diameter of a hurricane or distance across a meteorite crater using the properties of similar triangles. Let's work on an example to see how similar triangles are applied when aerial photography is used to find a distance. Assume that a blimp holding a camera 225 kilometers above a crater, segment CG, to take its photo. So it's straight above this crater. If the camera's aperture, segment AB, is 20 millimeters and the focal length of the camera, segment CF, is 90 millimeters, what is the distance across the crater, segment ED? The following figure represents the situation. Points F and G are the midpoints of segment AB and segment ED, respectively. Segment CF is perpendicular to segment AB and segment CG is perpendicular to segment ED. So what they gave us there that's not marked is that G is the midpoint of ED. That means E to G and G to D are congruent, and that F is the midpoint of AB, so A to F is congruent to F to B. So the question 1, to find the distance, we will first show the similarity of two triangles and use that similarity in our calculations. Notice in the figure that segment AF is parallel to segment GD. Therefore, alternate interior angles, angle A and angle D, are congruent. So if you cannot picture that, extend the segments. And here is transversal that they're talking about because it's the one connecting point A and point D. There's our angles. So again, visualize if there's a rectangle or a box. Are these angles right here, angle D and angle A, are they inside this box or are they outside of it? They're inside, and they are not on the same side, so they're alternate. And since they're inside, they're interior angles. Angle A and angle D are, and so they're congruent. We also know that the angle of AFC is equal to 90 degrees, A to F to C, and DGC is 90 degrees. Which of the following theorems proves that triangle AFC is similar to triangle DGC? So we had a 90 here and a 90 here. So we have two angles. Angle, angle. Similarity theorem. Refer to the image in the instructions. Since triangle AFC is similar to triangle DGC, the corresponding sides are in proportion. You can set up a proportion that will help you find half of the distance across the crater. What is the correct way to set up the proportion to find the half of the distance across the crater? Okay, since the proportions of corresponding sides have to be congruent, so I'm going to use R for my ratio. So the ratio for corresponding sides, and how will I know which ones are corresponding? So A is the first vertex listed, second vertex, third vertex. First, second, third. So when we're talking about corresponding sides, we need to make sure that the vertexes, say I go from the first vertex to the second vertex, in the other triangle I need to go from the first vertex to the second vertex. since we're trying to find half our length right here, DG, it's going from our first vertex listed to our second vertex. So I want to make sure that I have DG and its corresponding side, since it was the first vertex and the second vertex, I'm going to go A to F because that's our first vertex to our second vertex. So that ratio, and our is also going to be the same as G to C, our second vertex to our third vertex. So G to C. And in the triangle AFC, our second vertex is F, third vertex is C. So the segment would be F to C. We're talking about side lengths, the length between those vertexes. We're not talking about the vertexes themselves. They are helping us order corresponding sides. So since those two ratios are congruent, we can set the ratio of AF over DG equal to the ratio of FC over DC. Or they could list DG over AF and DC over FC. So what is the correct way to set up our proportion? I'm noticing in this first one they have DG right here, which is correct. Our ratios are just in reciprocals, so we need to flip them. So we could write or our ratio, since could equal DG to AF, or our ratio would equal GC to FC. So reciprocals means that the top and bottom are opposites. So now we need to just fill in that information with what they gave us. So they told us that the distance to the crater is equal to 225 kilometers. So that's the distance of DG. So I'm looking for this ratio set up. And since they're both equal R, we can use our transitive property. And I could say DG over AF is equal to GC over FC. And by substitution, GC is equal to 225 kilometers. And we know that their focal length was given of the camera is 90 millimeters, and that's from F to C. So FC is millimeters. Now that's going to cause unit issues because they have to be in the same unit. So we need to be checking that in our answer. We're looking for DG, and the size of our image is 20 millimeters, but A to F is only half that length, so it's going to be 10 millimeters. So AF is going to be 10 millimeters. So we need to be looking for a setup like this, and we've got to find one that has the correct or the same units. all the way around. So in here they all converted it to millimeters, which is great because this one was already 10 millimeters and 90. So we are looking for 225 million millimeters over 90 millimeters, which equals dg over 20. Nope, it's over 10. So the first one's off. 225 millimeters. No, it was 225 kilometers. So we have to convert that. And if you're struggling with how to convert from kilometers to millimeters, type in convert from kilometers to millimeters. So here we go. 1 kilometer. We had 225. Now this E plus 8, that means that there are 8 spaces past 25. So that means there's 1, 2, means there's 6 more zeros tagged on to the end of 2.25, which this has. And then we're looking for our third option. So the second option wasn't correct because 225 millimeters is not correct. It's kilometers. So then we have 225 million millimeters over 90 millimeters equals dg over 10 millimeters. That was our ratio. And it's okay if they're on opposite sides. It's an equal sign, so we can move those across. How long is the distance in kilometers across the crater? Okay, so in order to simplify or solve for the length of dg, we need to multiply by 10. Since it is in the denominator, we're going to use multiplication property. So we're actually using a reciprocal. So times by 10 millimeters times by 10 millimeters. And I'm noting to self that this really has 6 zeros written in here for it to be in millimeters. So then I would type in to this, I would type in parentheses 225 1, 2, 3, 4, 5, 6 divided by 90 parentheses times 10. And that is giving us okay, 225 1, 2, 3, 4, 5, 6 divided by 90. Okay, I just wanted to double check. Now we're going to times it by 10. So we have 250 million, 25 million millimeters. So in order to convert that, if you want to convert, type in convert millimeters to kilometers. I would type in 25, 1, 2, 4, 5. So it's 25 kilometers. That was only half of the distance. We only set this up for half. So our total distance, if this half is 25 and the other half is 25, our total distance is 50. Now it says find some other examples of other professions where similar triangles and their proportional relationships are used. Post your findings and explain with an example of how those concepts are used. So I would type in professions where professions that use similar triangles. And here's a list. Now it's going to be your job to look at it and find out what area they would use a triangle in. So, for example, if we click on architects except landscape and naval, I would Google triangles, similar triangles in architecture. And I want real life ones. So here's an example. And so I'm going to copy this. So copy image address, paste it, and then I'm going to say the windows would be proportional because we create parallel lines right here, right here, right here. And we can use our alternate interior, alternate exterior angles to prove similarity. And so that's what I would type in. So since parallel lines are created by the sides of the stacked triangles, we could use alternate interior angles to prove alternate interior angles and alternate exterior angles to prove angle-angle similarity in the triangles. So that is an example. I want a different picture besides this one, and a different job than architecture for this example. And I want different pictures in the last project. So if you submit a project that has the same picture that I had here, I'm not sure where it's at. As in the last video, then please change it and find a different picture with your own original work and original breakdown of that picture. So there's your project help.